Hey guys, welcome to the live stream. I'm going to be doing some leak coding problems. Um, my goal is to do one or two of these a day, depending on the difficulty, in order to prepare for coding interviews. I currently work as a software engineer, and in the next 2 years, I would like to get a job at a quote-unquote bigger tech company, um, just because um, I think the experience of working at a big tech company would be cool, and it's a good thing to have on a resume, especially for someone like me who comes from a non-traditional CS background. I think having a big tech company on my resume is really going to be beneficial. Um, but anyways, that's kind of some of the background of why I'm doing this. And yeah, so let's jump into it. I'm starting off with easy problems because I want to work my way up to the medium and hard ones. So let's do this reverse a linked list. And I'm actually going to be doing this in Go because that's what I currently use at work, and it's one of my favorite languages. Alright, so reverse a singly linked list. So a singly linked list is where you have a head and a tail, and in order to get to the tail, you have to start at the head and just go to the head's next node and then that node's next node, and just keep traversing down the linked list. So I'm thinking, it says a linked list can be reversed either iteratively or recursively. Could you implement both? So I'm thinking of doing it the iteratively way. So I'm just going to keep walking down the list until I get to a node whose next is null, or in this case, in Go's case, nil. And then I'm going to push that node onto a linked list, a new linked list, which will be the reversed linked list. And once I'm at the end, I can't really go back because it's singly linked. I have a really terrible idea that I could do. I could just go down the linked list till I get to the node with a next of nil, and then I can create a new linked list with that as the first element, and then I can restart on the reset to the head and go down till I get to a node which has that value. But then if the values are the same, that wouldn't work because I would stop one early. So let's see here. Traverse the linked list until I reach a node whose next value is nil. So for head.next equal nil. Current node pointing to a list node. So for every node, so start at the head and then say head is equal to, if it's not nil, head is equal to head.next. And then that should traverse down the entire linked list. So at this point, this should be the last element if I print that out. Okay, so after it's gone through that for loop, the head should now be the last node. Okay, which it is. So that needs to now be the first node. Okay, so if I make a new linked list, answer linked list, the pointer, oh, is a answer node. So answer node equals So as I'm going down the list, last element and the last element will be the first element. So as I'm traversing down the list, if I point each node back, if I take the head and set its, okay, if I take the head and if I take one past the head and I point it back towards the head and then go forward one step and then point it back towards the head. Okay. And then I just have to figure out how to make the first one's next node nil. Okay, so for head dot next is not equal nil. Say head dot next equals head. So that would be saying head dot next, which is 2, its dot next will now be 1. Okay, so head dot next equals head, and then I want to say head dot next. Well, let's save the next so I can replace it. So temp next equals head dot next. So I'm saving the next so I can replace it with nil. Okay. So this will be if I equals 0, then we want to set it to null because it's going to be the last. So points back, and then if it's the first node, we want to set it to nil, and then we want to say head equals temp next. Okay, so whoops. So what we're doing is we're starting at the head, we're starting at the first node. If its next is not nil, then we're saving head.next in this temp next, and we're doing that so we can replace head.next with nil if it's the first node. And then we're saying head.next. So go up one node and then say its dot next is now the head. So now it's pointing back. And then if it's the first node, we want to set it equal to nil, so it's the tail. And then we want to set the head to the maybe I should do the temp next here. Temp next. Man, that word next, the more I look at it, the more it just looks strange. Okay, so at this point, after the first iteration, we should have head equal to temp next, which is equal to, if we take this example, it is equal to 2 with its next pointing back to 1, and then we should have 1 pointing back to null, and then we'll iterate forward. And let's increment this so we don't set anymore to null or to nil. Okay, so then we go to the next node. So then we say head.next, which head is now 2. And then we say the next. Oh, but now that is pointing backwards. Now that's pointing backwards. So if I do temp.next, it's just going to be nil. Because temp.next is nil. Oh, no. Head.next. And then temp next dot next. But I also want, so I updated its next, but I also want to go forward. So I need to save it. Oh man, so if I have a variable out here called previous next, then I can just mess with this inside the loop. And so each time through, I will set this to previous next equals temp next dot next. Okay, so that's saving the actual next if I'm going forward. And then I've replaced the next with the head node. Equals head.next. Equals previous next. Previous next dot next. If previous next. I have no idea if this is even close. I'm going to print out previous next. I'm going to print out next. next. Colon there. So I think I kind of get the basic idea. I need to traverse through the list and change each next to point in the opposite direction, except for if it's the head, I need to point it to nil. And so that changing of direction requires me to save the forward direction next in order to traverse the list, but also flip the next so it's in the proper reversed order. Yeah. Previous next. So previous next is actually nil at the end. So that's good. Let's see, how do I print this out and see what I'm getting? Leave that there. Previous next. So let's just print out the list. I'll just go through it. So for previous next head equals jump to next previous next head equals to next. So is head gonna be the actual list? Not next. Am I changing that head? Val. What is that gonna be? 5, 4, 3, 2, 1. Maybe it's busted. Well, that's not good. Uh-oh. So I just have an infinite amount of 5s. Well, I got the first input, right? The head should be 5, right? The head should be 5. So let's go through it again. So I think my naming needs to be a lot better. So this is what I'm trying to do here is I'm trying to save the forward iteration of the list. I'm trying to save that so I can update the list to point backwards. So let's say save forward next. So this way I'm going to preserve the ability to go down the list. So I'm saving the next node so I can jump to that node. And then I'm saying, okay, so while the save forward next is not nil, okay, take the save forward next and take its next. So let me get this little piece of paper here. So I'm on node 1. Okay, so save forward next on the first round through equals 1.next which is 2. So that equals 2. And then I say 2 dot, okay, and then I say 2 does not equal nil, so I go into the for loop. And then I say save forward next dot next, so that would be save forward next next equals 2, 3, so that's 3. So temp next, and that equals temp next, and I'm saving that temporarily so I can overwrite it and not lose it. And then I'm saying save forward next equals temp next dot next. So then I say save forward next equals temp next dot next. So that would be equal to 4. So now I'm all the way down to 4. Temp next dot next. And I say temp next. Whoa, I'm doing some crazy stuff here. All right, let's. I think I was thinking it through that time. So let's reset, just so I can get a clear head. Because I was doing some crazy stuff. So I know this problem is probably pretty easy, but I mean it says easy, but it's my first time doing a problem like this. So I have worked a decent amount with linked lists, but I've never actually reversed one. So this is good. I'm learning. So let's reset. So we're saying head dot next. I don't like that. Let's reset it. Head dot next does not equal nil. So while there's a next node to go to that next node. Okay, now what do I want to do? If it's the first node, I'm going to use this outer counter. So if I equals 0, then I want to set head dot next equal to nil. Oops, equal to nil, because I want the head to become the tail. But before I do that, I need to save what the actual next is so I can traverse. Otherwise I cut off my path and I can't go to the next node. So I need to save next equals head dot next. Okay. Now I have a question. This is more of a Go question. If I print out next here, is that going to be nil? Is this going to affect, because it's a pointer, so is this going to affect up here? Because so this is a pointer, so it's storing a address. It's storing in this next value, it's storing an address pointing to a node. And then I'm taking this and pointing I'm going to that node and setting it to nil. Ooh, let's see. So next might be nil here if I do it this way. Oh no. Okay, so it preserves it. That's good. That's good. Okay. Okay, so if it's the first node, I just want to set its next to nil, but I want to save its actual next, and so I can go to that next node. Okay, and then I want to say head equals next. So then I go to the next node. Okay, and then I check if, okay, and I also have to increment I here, so I don't do this anymore, only for the first one. So now I'm on the next, now I'm on 2. Okay, and so now I say 2 dot next, so head dot next, which is going to be equal to 3. It doesn't go in the if statement. Okay, so now my goal is to set 2's next equal to 1. Point it back to 1. The problem is I no longer have a reference to 1. So let's save that. So that's why I had the outer variable. Var previous node equals. We'll start it out as head. Okay, we'll start that out as head. And now, previous node. Okay, so if the previous node, it's already set. No, we'll do it every time. So previous node equals a pointer to a list node. So this previous node is what I'm going to use to save is what I'm going to be able to look back 1 in the tree, basically. So so head.next equals next, so that's moving up the tree, but I need to save the previous. Before I do that, I need to save the previous node equals head. Okay, so if I print out previous node here, and then I print out head, on the first time through, I should see this as 1 nil, and this as 2 3. Right? So this is 1 nil, 2, pointer to probably 3, right? Okay. Okay. Okay, so now I have this previous node saved, so I can point the head back. So if it's the first, we want to set it to nil. If it's not, we want to set head.next equal to that previous node. And then we want to update that previous node to the head, so the next one can point back to it. Okay, so let's run that. Okay, so start at the head, go to the next node, save it. If it's the first node, set its next equal to nil. Otherwise, set its next equal to the previous node. Okay. Wait, no, we always want to do this. Yes, we always want to do that. That next equals previous node. Oh, ooh, actually, so that's previous node is going to be nil if it's the first one, so I don't even need this. That's kind of nice. So let's print some stuff out to see. So I'm going to print out, actually, I just want to print out everything. So for head.next does not equal nil, print out head.val. Let's just see what's going on here. Input for So head.next must be equal to nil. Well, what node am I on? What is head when I get to the end here? So, okay, so head is 5. That's good. That's what I want it to be. But I want it to be pointing back to 4, not to nil, because I'm broken here. I can't go anywhere from this node because my next doesn't point anywhere. So for some reason, it didn't go in. Oh, it's okay. Okay, so I was on 4. I saved next. I saved 4's next, which would be 5, and then I set head dot next equal to previous node, so that should say 4 points back to 3, and then I say previous node equals head, which should be 4, and then I say head equals next, so that should be 5. Yup. Oh, and then head.next doesn't equal nil, so it doesn't go into that loop again. So, okay. So it doesn't go into that loop. So maybe I just add one more at the end of the loop. Just like one more iteration of stuff. Like this. I don't know. Just because it needs to run one more time outside the loop. Standard out is nil. Print head. Okay, but don't do that. Next declared and not used. Okay, okay, I don't know. Maybe I don't have to save that anymore. Okay, so oh, perfect. So I have 5 and it's pointing to a node, which I hope is 4. So let's go print, so 4 head.next does not equal nil. fmt.print line head.val, and then we'll say head equals head.next. Okay, so this should traverse it and print out each. Okay, so 5, 4, 3, 2. Oh, sweet. Okay, so I think it's reversed. So if I just return head here, it should work. It should have a pointer back to 1. Awesome. Okay. So it took me a while to kind of wrap my head around it, and I started off on kind of a really confusing path, and I had a bunch of extra stuff that I didn't need. It was confusing me, but at the end of the day, what I'm doing is I'm going through each node in order. I'm traversing the list forwards, and then at each point I am flipping the next. So I'm pointing it's the next backwards. So in the case of the first node, it's going to be pointing backwards, which is going to be pointing into nil. So 1's going to be pointing into nil. And then I move forwards, and then I point backwards, and then I move forwards, and then I point backwards. My issue was when I moved forward, I didn't have any reference to point backwards. So that's why I have to save this next value, or this previous node, outside the for loop, so I always have a reference to the node, the iteration of the node in the iteration of the for loop one before. It doesn't make sense. I'm not doing a good job of explaining it. So this previous node is basically living outside the for loop, so that when I'm on iteration 2 of this for loop, I know what node I was on iteration 1, and that way I can point iteration 2 of the for loop back to the node that was active on iteration 1. I hope that kind of makes sense. That was the biggest issue I had, because I lost reference to that previous node. But once I kept that outside the for loop here, now I can set nexts backwards to that previous node. And I originally had a weird if statement in here that was like checking if it was the first node and then setting it to nil, but I realized if I just started this previous node off as nil, it's going to set the first one to nil, and then once I update it right here, it'll set all the other ones to the one right behind it. And then I just update, so I update the previous node so it points to the one back, and then I set the head just to the next, so I move forward in the list, and then I check if that head is next. So, and then it stops one early because the last element is next is nil, so it's not going to enter in here. So I had to do it one last time just to catch the last one. So let's see if I know there's always like edge cases and stuff that it probably will fail on, but let's see. Invalid memory address or nil pointer dereference. Okay. Last executed input. Oh. So if the head is nil to begin with, we can't loop through it. We can't access next of a nil. So I have to check for that. I wonder what it wants me to return if it's so let's add that to the test cases. Empty. So if we'll just put at the top, if head equals nil, then I just want to return what? Nil. Expected output, okay. Okay, so that catches that edge case. That's good. Okay, cool. Success. 0 milliseconds. Dang. I don't know why it always does this, but it always says like my solutions are super fast, which I know they're not, but I think it's just like because not as many people have solved it in Go or something. I'm not sure. It's 0 milliseconds. I don't know why it does this. If anyone knows, let me know, because this is definitely not accurate. Well, maybe, I don't know. Maybe it just doesn't have that granularity. Maybe it doesn't go down to like the microseconds or whatever. Okay, 2.5 megabytes, less than 99.81% of Go online submissions. So I think that's just because not that many people have done Go, because 2.5 megabytes, like, I don't know. I feel like that's not that good. But should we look? So I think once it's accepted, I think I can just look at solutions, right? Okay. 40 milliseconds beats 99. 40 milliseconds. See, there's no way mine is 0 milliseconds. Like, that doesn't make any sense. With visual animation. So iterative. Assume that we have a linked list 1, 2, 3, nil. We would like to change it to nil 1, 2, 3. Okay. So while you're traversing the list, change the current node's next pointer to point to its previous element. So that's exactly what I did. My issue was saving that previous element. Since a node does not have reference to its previous node, you must store its previous element beforehand. Yeah, So that's what I was doing outside the for loop. You also need another pointer to store the next node before changing the reference. Yeah, because you need to set the first node to nil, but then if you did that, you wouldn't be able to go forward in the list. So you need to save the next. Okay, so that's what I'm saving here. Okay. Do not forget to return the new head reference at the end. Okay. So yeah, that's exactly what I'm doing. I have a list, I have a previous node I'm saving outside my while loop, and go for, there is no while loop. For is the same as a while loop. Okay, so while it's not null, list.nextTemp. Okay, so save the next, then update the current.next to the previous, then set the previous to the current so you can have it for the next iteration, and set the current to the next, so traverse, so step forward in the loop. So it's basically, okay, save your next, okay, so you can override it. Then override it with the previous. Then save the previous so you can point backwards for the next node. And then update your current node to go forward in the list, and then just return the head. So yeah, I pretty much did exactly what they did, except for I have this extra one. I have to do this extra once outside the for loop. I'm not sure why, but so it's O of n. N is the list length. The time complexity is O of n. So for however many inputs, it's going to take that same proportional amount of time. Space complexity is O of 1, so it doesn't use any extra space. Recursive. What's recursive? O of n and O of n. Huh. So recursive seems like it's worse in every way. Or the same. O of n, and then space is O of n. And the iterative is O of 1. I like the iterative approach better anyways because it's just easier for my brain to think about iterative solutions. In this case, sometimes you do need to use recursion and it makes more sense to use recursion, but in my brain, iterative is usually more straightforward unless it's a unique problem where recursion makes a lot more sense. Okay, cool. I still can't wrap my head around head.next.next equals head. So the current node's next node, so go 2 forward from where you're at and set, go 1 forward from where you're at and set that value equal to the head. So you're just flipping it. You're just going 1 forward and then pointing that node's next backwards to the head. So it's just flipping it backwards. And then head.next equals null. That's just saying if it's the first, then you're pointing it back to nothing, so it has to be equal to null. Why bother when the iterative solution is better and easier to implement? It's nice to use recursion just to practice it, but I think the iterative is definitely better. Unless you just understand the recursive approach much better. In that case, it might be better to use that, but let head's next node point to the head itself, and then let head point to null. Okay, well, that was fun. I think I'm just gonna do one today because I want to work on a little project with my brother. I'm trying to learn Haskell, make a little web server with Haskell. So I think I'm gonna call it quits for today with LeetCode problems, but this was a good one. I'm starting off super easy. I know most of these problems are, if you've been doing LeetCode for a while, they're probably extremely simple, but it's my first, couple weeks doing LeetCode, so I thought I'd start off easy. I didn't want to get too frustrated and stuck on one problem for like days at a time. So yeah, I'm calling it quits. Thanks for watching. Hopefully you learned something. If it was super easy and you already knew the solution, you're probably like banging your head against the wall. Why is this guy? He doesn't understand. But I'm getting better. I'm working